Good morning, students. Welcome to Elimu Live, one of the best TV shows in matters concerning education. And today with you is Mr. Allan Yonga, a maths and chemistry teacher at a school in Kiambu County called St. Joseph, Riabai. Today I'll be handling chemistry. Though, as I've indicated earlier, my other subject is mathematics, and most of our students and candidates had requested we handle the topic moles. So that's the topic I'll be handling today, moles. Moles is a very wide topic. Actually, it takes almost a term to complete. But in my lesson today, I've tried to summarize and make it as simpler as possible for you, for the viewers at home, so that you may understand. And the first, for you to understand the topic moles, you need to go back to your Form 2 work of writing balanced chemical equations. But moles usually go hand in hand with balanced chemical equations, because from the balanced chemical equations, that's where you get the mole ratio. So join me in this journey and keep your pen and books ready, and let's make moles easier. So since my notes are in hard copy, we'll start with definitions, and I'll dictate the definitions of these terms. So the first term we are defining is the word moles. So moles is one of the basic unit. There are 7 major basic units, and an example is Kelvin, an example is length. Moles is also another unit for measuring the amount of substance. So in short, you can define it as the unit of measuring the amount of substance. We don't use grams in chemistry, we use moles, because you will find out that 5 grams of copper and 5 grams of aluminium, though they have the same mass, they don't have the same number of moles. So I hope that is clear. It's the unit for measuring the amount of substance. The second term we are defining is molarity. Molarity. And molarity mainly goes with solutions. So molarity mainly goes with solutions. And you can define it as the number of moles per liter in a solution. The number of moles per liter of a solution or in a solution. The number of moles per liter in a solution. So you can say 0.2 m HCl. HCl is the chemical symbol of hydrochloric acid. So when you see 0.2 capital M, that's now the unit for molarity. What it means HCl has 0.2 moles in 1 liter. HCl has 0.2 moles in 1 liter. The other term we define is concentration. Concentration and molarity still, they are almost similar. The difference now is concentration is the number of grams, the mass in grams per liter of a solution. So the difference is molarity is moles per liter, while concentration is grams per liter. So the amount in grams per liter in a solution. And for it to indicate in grams per liter, where the slash stands for per. So like I can have 2 grams per liter. 2 grams per liter. So this is concentration. And you can convert concentration to molarity. We'll look at that later. We check how we can convert concentration to molarity. The other term to define is empirical formula. Empirical formula. Sometimes they indicate it as EF. EF. So empirical formula, it's the simplest, it shows the simplest whole number ratio in which atoms combine to form a compound. It shows the simplest whole number. The key word is whole number, not a whole as in full. Whole number, it shows the simplest whole number ratio in which atoms combine to form the compound. Let me give you an example. An example is water. The symbol of water is H2O. So the atoms which form water is hydrogen and oxygen. In which ratio are they combining? H2. So the ratio is 2:1. So this is the empirical formula because it shows you the simplest ratio in which the atoms combined to form your compound, which was water. And the ratio is not in decimal point or in fraction point. That's why we had emphasized simplest whole number ratio. Let's move to molecular formula. Molecular formula. Molecular formula is related to empirical formula. And what it shows the actual number. The definition of molecular formula is it shows the actual number of each kind of atoms combining to form a compound. It shows the actual number of each kind of atoms combining to form a compound. Back to your Form 1 work, you define a compound. It's a substance made up of 2 or more atoms which have combined chemically. Let me give you a good example. Benzene. We have benzene. The molecular formula of benzene is C6H6. 6 carbon atoms combining with 6 hydrogen atoms. This molecular formula can be empirical formula. How? CH. It means for each, the simplest ratio is 1:1. If you simplify 6 and 6, the simplest ratio is 1:1. So it means when you have an empirical formula, it can give you the molecular formula. So I hope you are good with those 5 definitions. If you have any inquiry, please use the numbers which are below your screen to WhatsApp us, or you can also comment on Facebook Live. Follow KUTV. Let me now move swiftly to major formulas which you need to know when you are handling questions regarding moles. And the first 2 formulas, I'll represent them in a triangle so that the student at home, it's easier for you to understand and grasp them. The first one, we have this triangle here. And on top here, I'll write mass. Here, I'll write number of moles. And here, I'll write molar mass. Molar mass, sometimes some books will refer to as relative formula mass, RFM, or relative atomic mass, RAM. So how do you understand this triangle? It means mass, when you want to calculate mass equals to number of moles times molar mass. Mass equals to number of moles times molar mass. What about number of moles? Number of moles is mass over molar mass. What is molar mass? Molar mass is mass over number of moles. This triangle mainly applies for solids. And in solids, the elements, chemistry we deal with elements, and most solids are metals. So mainly it will be involving metals and other compounds which exist in solid form. The other triangle, on top here now, I'll write moles, the number of moles. On top there, I write number of moles. Then here we write molarity. Molarity. Then here, volume in liters. Volume in liters. This one mainly applies for solutions. And these solutions in chemistry, the major solutions are acids and bases, and sometimes soluble salts. So how do you understand the triangle? Moles, number of moles is molarity. And remember I defined molarity earlier. So if you can refer to your earlier notes to check the definition of molarity. So moles is molarity times volume in liters. What about molarity? Molarity is moles over volume in liters. When you want, one thing you have to remember when you're talking of volume in liters is 1 liter is equals to 1,000 centimeter cubed. That's how you convert a liter to centimeter cubed or centimeter cubed back to a liter. A liter is the same as 1 dm cubed or decimeter cubed. So 1 decimeter cubed is the same as 1 liter. So it's still the same as 1,000 centimeter cubed. So those are the first two triangles. The first one is for solids, second is for solutions. The other now we have molar gas volume. Molar gas volume, which applies now for gases. I'm still on the major formulas which will help you to tackle questions on moles. So molar gas volume. And from the word itself, it means it applies for gases. Molar gas volume. And here we have two scenarios. RTP, room temperature and pressure. When you are measuring the volume of a gas at room temperature. We also have STP, at standard temperature and pressure. Because the molecules of gases are far apart, they don't have definite volume. That's why their volume, sometimes we refer them when it is at RTP, which is room temperature and pressure, or when it is at STP. Our room temperature is 25 degrees. STP is when the temperature is at 0 degrees Celsius. So what does it state at RTP? That 1 mole of a gas, its volume equals to 24 dm cubed. 24 dm cubed, which if you go back to this formula, is the same as 24,000 centimeter cubed. At STP, it says 1 mole of a gas, its volume is 22.4 dm cubed. Dm cubed is the same as a liter, which when you convert it to centimeter cubed is 22,400 centimeter cubed. So at home, digest those 3 triangles, because those examples which we are going to look at, they'll involve these 3 formulas. And 99% of questions involving moles revolve around these 3 formula. So that's the key point for you to understand, so that moles, the topic moles, can become easier. And moles usually comes in paper 1, sometimes paper 2, and also in titration, paper 3, where it also can help you to get more marks. So questions on moles in paper 1, they take 3 marks. So that's why I'm saying it's better or good for you to understand the topic. So I'll look the first example where we use this formula. And the first example is involving empirical formula and molecular formula. Go back to your definition so that you can see what they mean, the 2 words, empirical formula and molecular formula. So you can answer questions, you can calculate empirical formula and molecular formula using this question. So I have here a past KCC question which was carrying 3 marks. It says a hydrocarbon Hydrocarbon means it's made of hydrogen and carbon. It's an organic compound. Contains 92.3%. 92.3% carbon, and the rest hydrogen. Calculate. So if it has a molecular mass of 78, if it has a molecular formula of molecular mass, not molecular formula, Molecular formula is what we are supposed to calculate. If it has a molecular mass of 78, calculate its molecular formula. So I'll do the solution here. The hydrocarbon contains 92.3% carbon and the rest hydrogen. So we'll need a calculator. So I want you to put your calculator ready. We want to calculate the number of the molecular formula. So you usually draw a table here and you write the elements. Which elements make up the compound? So we have carbon and hydrogen. Then the second part, you write now the composition. Percentage composition. Percentage composition. So a hydrocarbon contains 92.3% carbon. So this one is 92.3, and the rest is hydrogen. So if the rest is hydrogen, our total percentage adds up to 100. So you do 100 minus 92.3. That gives you 7.7. Second step, you'll always be given the RAM. So carbon, the RAM is 12. Hydrogen, the RAM is 1. So you don't need to cram the RAM. For you to understand the RAM, go back to your Form 2 topic of periodic table. You'll understand the definition of RAM. But to make it easier for you, you don't have to cram the RAM of each element. So second step, you go to RAM or molar mass. In this triangle, we are referring to it as molar mass. So the RAM of carbon is 12. The RAM of hydrogen is 1. Then now you go to mole ratio. We had indicated empirical formula is the simplest mole ratio or whole number ratio. So here we go to ratio. We want to calculate the number of moles. Our percentage composition also acts as the mass, because if the compound, the mass was 100 grams, it means carbon will be 92.3 grams and hydrogen will be 7.7 grams. So always your percentage composition will act as mass. In some questions, you'll be given the mass in grams. Some questions you are given the percentage composition. So moles is mass over molar mass. So here it's 92.3 over 12. And here is 7.7 over 1. So 92.3, you can also do it at home. You tell me your answer through the text or WhatsApp number which you have below your screen. So we have 92.3 divided by 12. That gives you 7.7 when you round off to 1 decimal places. So moles. Here is moles, sorry, not ratio, moles. 7.7. 7.7 divided by 1 is still 7.7. So percentage composition, RAM, there was no calculation. Moles you have to calculate using your triangle. Then the last step, now you get the ratio. Remember, empirical formula and molecular formula, they should be in whole number, not in decimal number. So I get the ratio. So to get the ratio, you divide both moles by the lowest number of moles. So this is 7.7 and 7.7. You divide both by 7.7. The lowest number of moles. So if this was 5.2, I'll divide both sides by 5.2. So here 7.7, 7.7. So the ratio is 1:1. So the empirical formula is CH. That is the empirical formula, CH. Let me add you another formula for calculating empirical formula and molecular formula. The formula is empirical formula times N equals to molecular formula. Empirical formula times N equals to molecular formula. Another thing, empirical mass empirical mass times N equals to molecular mass. Empirical formula times N equals to molecular formula. Empirical mass times N equals to molecular mass. So CH is empirical formula. The question wants you to calculate molecular formula. So it means now you have to go to the next step of calculating N. So I'll get the empirical mass of CH. Mass, you use the RAM, or the molar masses. So CH is 12 and 1. So that is 13. So you say 13 times N. I'm using this formula. Empirical mass times N equals to molecular mass. What was your molecular mass? If it has a molecular mass of 78, so your molecular mass is 78. So what is N? You have to divide both sides by 13, which will give you 6, if I'm not wrong, which will give you 6. So N is 6. You're not interested in N, you're interested with molecular formula. What is molecular formula? Empirical formula times N. So it means this is C1, because it was 1, 1. C1, H1. So each number I'll multiply by 6. So your molecular formula will be equal to C6H6. C6H6. It's very simple. It might look like it's a long process, but if you understand the formula here, makes it to be simple. Percentage composition you are given in your question. RAM you are given in your question. Moles is what you need to calculate, and moles is mass over molar mass. When you get the moles, you have to turn them to whole ratio. How do you turn them to whole ratio? You divide by the lowest number of moles. So here it was 7.7 and 7.7. So you just divide and get 1, 1. This ratio gives you the simplest ratio. And we say the simplest ratio is the empirical formula. So empirical formula, then for you to get molecular formula, please also you can add these two formulas, which will help you to get the value of N. So CH, since the RAM of carbon is 12 and the RAM of hydrogen was 1, so 12 plus 1 gives you 13. Then 13 times N equals to 78. Then you get N is 6. Then I've said molecular formula is empirical formula times N. So if I know my N is 6, and this is my empirical formula, 1 times 6, you get 6. Another 1 times 6, you get 6. So the formula of that hydrocarbon is C6H6. Another question which appeared in KCSE, in past paper of KCSE, I'll dictate it for you, then you can attempt as we continue with other content. So the question goes this: a compound contains 69.42% carbon, 4.13% hydrogen, and the rest oxygen. If its molecular mass is 242, calculate its molecular formula. Let me repeat it. A compound contains 69.42% carbon, 4.13% hydrogen, and the rest oxygen. If its molecular mass is 242, calculate its molecular formula. Then I've said that RAM, you don't have to worry about RAM. You'll always be given the RAM. So here in that compound, we have 3 atoms or 3 elements. So let me give you the RAM of those 3 elements so it can help you to handle the question. So carbon, RAM of carbon is 12, a very common element. RAM of hydrogen, another common element, is 1. And RAM of oxygen is 16, another common element. Swiftly, that's where we apply the first triangle or the first formula in calculating, where we apply the first triangle in calculating empirical formula and molecular formula. This other triangle, you'll apply it in titration when you are doing practical papers in titration, and because of time, we cannot handle that part of titration. But if you understand the second part, which I'm going to look at, then it's easier even to handle questions which are regarding titration. So the other questions which I'll be handling, which involves this triangle, are now questions which appear in paper 1, mostly in paper 1. And these questions, you need to know how to write a balanced chemical equation. If you don't understand how to write a balanced chemical equation, that should be your first practice before you start handling questions regarding moles. Because that's the first step. In every question, you'll observe that. Writing a balanced chemical equation. So let me give the first example. Okay. So the first question is 1.96 grams of zinc reacts with hydrochloric acid. Reacts with hydrochloric acid to produce hydrogen gas. Calculate the volume of hydrogen gas produced at STP. Calculate the volume of hydrogen gas produced at STP. So also it means you'll have to apply this formula of molar gas volume. So I'll do it on this part, how we're supposed to go about that kind of question. And just a reminder so that you can remember your Form 1 work, in preparation of hydrogen gas, you react zinc metal and hydrochloric acid. So the question wants you to handle, if you use 1.96 grams of zinc, what volume will you get of hydrogen gas? If the conditions are at STP, that means at 0 degrees temperature. So that's what I want you to observe how you calculate such a question. The first step I've said is writing the balanced chemical equation. When this zinc and hydrochloric acid are reacting, what are they forming and how are they balancing? So first, here you'll be given the STP of zinc. The RAM of zinc is 65, not 64. Wanted to write 64. 64 is copper. So first write the chemical equation. Zinc is Zn, and it's a solid. That's why you have indicated in brackets solid. Plus hydrochloric acid is HCl. It's an aqueous solution, so you put AQ. And which reminds me of students of Aquinas High School. I hope you are also locked in. To give you zinc chloride, ZnCl2. So these are Form 2 work. You need to work on writing balanced chemical equation. So you get zinc chloride. It's also a solution, so AQ plus H2, hydrogen gas. That's why I indicated it in G. So that's your products. Second step, balance the equation. I have 2 chlorine atoms, 1 chlorine atoms. 2 hydrogen atoms, 1 hydrogen atom. So to balance it, I'll put a 2 there. Then everything is balanced. Zinc is 1, zinc is 1. 2 hydrogen, 2 hydrogen. 2 chlorine, 2 chlorine. So the balanced chemical equation gives you the ratio in which zinc and HCl and zinc chloride and hydrogen. So if there's no coefficient here, it means it is 1. If the coefficient is 2, the ratio is 2. If there's no coefficient, it's 1. If there's no coefficient, it's 1. You don't take the 2's, the small ones, or those which are written below. You take the one which you had used to balance the equation. So having done that, now you get the number of moles. Which one can you calculate the number of moles? We can get the number of moles of zinc because it was 1.96 grams. And how do you calculate the number of moles? Mass over molar mass. So number of moles of zinc equals to, what's the mass? 1.96. What's the molar mass? Molar mass, you don't have to worry, always given 65. Then you divide. So you can also do it at home. 1.96 divided by 65. That gives you 0.03 in 2 decimal places. 0.03 moles. So with that now you can, if you know the ratio, you can get the number of moles of each reactant and each product which you are occurring in your chemical equation. So here we are interested with hydrogen. Calculate the volume of hydrogen gas produced. So I want to know the number of moles of hydrogen gas. So here, the number of moles will be 0.03. I've calculated for zinc. For HCl, because the ratio is 2, it means it doubles. So here the number of moles are 0.06. Here, zinc chloride, the ratio is still 1, so it's still 0.03. And hydrogen gas, 0.03. 0.03. You don't want the number of moles of hydrogen gas, you want the volume of hydrogen gas. So I indicated earlier, sometimes you'll be forced to use 2 formulas, or even all the 3 formulas. Major formulas are these 3. So since you're interested with the volume of hydrogen gas, come back to molar gas volume. They are said at STP. At STP, 1 mole, the volume is, so you can use both. If they have not indicated in which unit, centimeter cubed or decimeter cubed, I can prefer decimeter cubed. So 1 mole equals to 22.4 decimeter cubed. But it's not 1 mole which was produced. How many moles were produced? 0.03. What about 0.03? Then you do cross multiplication. Cross multiplication means you do 0.03 times 22.4 divided by 1. So join me in doing it so that you don't lose me. So we have 0.03 times 22.4 giving you 0.672. So volume of H2 equals to 0.672. Where did it come from? It came from 0.03 times 22.4 over 1. We did cross multiplication to get. So I hope you have understood how to calculate the volume. So if you are with me, you can see that we only apply the one of the formulas, or 2 or 3 of the formulas. First step, write a balanced chemical equation. Then check which among the elements which are reacting, or the compounds which are reacting, and the products which have been formed, which one can you calculate its number of moles. Then the balanced chemical equation will help you to get the ratio of the compounds reacting. Then if you know the number of moles of one compound, you can use the ratio to get the number of moles of the other compound. Then sometimes you can also be asked, what mass of zinc chloride was produced in grams? What mass of zinc chloride is produced? So if you know the number of moles, you still go back to the formula. Mass is number of moles times molar mass. And in that question, you'll have been given the molar mass of zinc and the molar mass of chloride. So it will be easier to calculate the molar mass. Another question, which also was tested in paper 1, carrying 3 marks, still on moles. The question is, let me write it here so that it will be easier to explain, and we can get the values easier. So you can also be writing at home as I'm writing, so that when during your free time you can refer to the examples, then you digest them slowly. So question 2, calculate the mass of zinc oxide. Calculate the mass of zinc oxide that will neutralize will neutralize dilute nitric 5 acid containing 12.6 grams of nitric acid in water, containing 12.6 grams of nitric 5 acid in water. So just to maybe analyze or explain the question, because the first step is usually good to understand the question. So first, the reaction is a neutralization reaction. An acid, usually acid, they exist in solid form. There are some acid which exist in solid form. So for you to make it to be in solution form, you dissolve it in water. So this nitric acid, they are dissolved 12.6 grams of nitric acid in water. So they want what mass of zinc oxide will neutralize it. Then you have been given this RAM. For zinc, you have been told is 65. For oxygen, you have been told is 16. And for hydrogen is 1. And nitrogen is 14. So it means you have to use this molar mass. Remember, molar mass is one of the formulas. It's involved in the formula. So that's why you have been given the RAM. So first step, as I always say, is writing a balanced chemical equation so that you can know the ratio. And the ratio helps you to know the number of moles for the other compounds which you didn't know their number of moles. So it's a neutralization reaction. A neutralization reaction gives you salt and water as your products. So the first step, at least you know, you'll get salt and water. So zinc is Zn, it's a solid, plus nitric acid is HNO3. An acid is always aqueous. So you'll get zinc nitrate, ZnNO3 brackets 2. Form 2 work will help you to know why the formula comes to that, plus H2O, water, which is liquid. And this one is aqueous, plus H2O. I hope it's clear at home, the word H2O. Second step, balance your chemical equation so that you have the mole ratio. So here NO3, you see all these nitrates, they are 2, but here NO3 is 1. H2O, hydrogen are 2, hydrogen here are 1. So you put, it's 1, hydrogen is 1. So you put a 2 here. So you'll have both 2 hydrogen and both 2 nitrates. NO3 is what stands for nitrate. So the equation is balanced, so the ratio is 1 is to 2 is to 1 is to 1, because there are no numbers here. But here there's a 2. Then second step is to calculate the number of moles. Which compound or product will you be able to calculate its number of moles? So I check, I have 12.6 grams of nitric acid. So I can calculate the number of moles of nitric acid. So number of moles of HNO3, mass over molar mass. So 12.6 grams. Its molar mass, you'll have to use the formula. So it's HNO3. So molar mass, let me give you the mole, how to calculate its molar mass. So molar mass, we have 1 hydrogen, 1, plus nitrogen is what? 14, plus O3. O3 means there are 3 oxygen. So 16 times 3, which is 48. That gives you 15 plus 48. 15 plus 48, 63. So the molar mass is 63. 1 plus 14 plus 16, 3 times 63. So number of moles will be 12.6 divided by 63. So at home you can do it together. 12.6 divided by 63. You get 0.2. So here the number of moles are 0.2 moles. So how many moles here? 0.2. 0.1. Sorry. The ratio is 1:2. 0.1. Ratio is 1:2. So it means you have to double this number to get this, or you have to divide this number by 2 to get this. So here it's 0.1, and here 0.1, here 0.1. So you have the number of moles. What's the question asking you to calculate? Calculate the mass of zinc oxide. How do you calculate mass? Number of moles times molar mass. So mass of zinc oxide, is number of moles. The ratio I'll help you to get the number of moles. So that is 0.1 times, we have to calculate molar mass. Remember I'm saying number of moles, mass is number of moles times molar mass. So ZNO is zinc and oxygen. So that's 65 plus 16. 65 plus 16, 81. So mass is 0.1 times 81. You get 8.1 grams. You get 8.1 grams. Let me repeat the steps so that at least you can get it well or correctly. First step, writing balanced chemical equation. If you're not good in writing balanced chemical equation, then you might see as if we are talking Greek. But let me encourage you, you have this time, please go back to your Form 2 work on writing balanced chemical equation. So we have here our balanced chemical equation. It helps you to get the ratio of each element. When you have the ratio, now calculate the number of moles of an element which you have been given. Go back to your formula, you check from what I've been given, which compound can I calculate its number of moles. So since in my question I've been given 12.6 grams of nitric acid, if I have mass, I can get the number of moles. Number of moles is mass over molar mass. I calculated the number of moles of nitric acid. 63 was the molar mass. You add H1 plus nitrogen is 14, that's 15, plus 3 oxygen. 3 oxygen are 48 because of 16 times 3, which gives you 63. Then you do the division, 0.2 moles. Ratio helps you. So because you are interested with mass of zinc oxide. Sorry for this mistake. This was ZNO, zinc oxide. I hope you can correct it, though it doesn't affect our equation. Zinc oxide. So ZNO, you do 65 plus 1. We want the mass of zinc oxide. Sorry, I'll have to correct something small here. I hope you can help me. So we want the molar mass of zinc oxide, which is 65 plus 1. So here should be 66, not 81. 66, not 81, to give you 6.6 grams. That's why it's always good to go through your working. At least you'll be able to notice where you went wrong and correct it so that you don't lose the marks. So because it's zinc oxide, you do 65. I was correct. I was correct, sorry. 65 plus 16. 65 plus 16. That gives you 81. Then you get 8.1 grams. So please go through the working slowly and try to digest it. And that can earn you 3 marks. And it doesn't even take a lot of calculation. So I can do the last example, then I'll leave you with the assignment which you can handle. Still, the examples are where you'll be using the 3 formulas. So example 3. So example 3 is 1 grams of a certain carbonate. 1 gram of a certain carbonate. So we don't know the carbonate, if it's magnesium carbonate or, so we just write it as GCO3. Reacts completely. reacts completely with 20 centimeter cubed, with 20 centimeter cubed of 1 molar hydrochloric acid. 1 molar hydrochloric acid. Calculate the RAM. Calculate the RAM of G. Calculate the RAM of G. So G is just an unknown element. We don't know which element it is, but we can get its RAM using these 3 formulas, using either 2 of the formulas or 1 of the formulas. But always I've emphasized each and every question, the first step is writing the chemical equation. So you need to know when a carbonate reacts with an acid, what products you get. So a carbonate plus an acid, you get water, carbon 4 oxide, and salt. Water, carbon 4 oxide, and salt. So we'll write the chemical equation. So our chemical equation is G carbonate plus HCl, or hydrochloric acid. G carbonate, which is GCO3. CO3 stands for carbonate. So G CO3, it's a solid, plus HCl, aqueous, to give you, the salt will be G chloride. From this formula, it tells you the valency of G is 2. That, because there is no number which has been put. So the valency of G is 2. That's why the formula becomes GCl2 plus H2O plus CO2. G chloride plus water plus carbon dioxide. This one is aqueous, water is liquid, carbon dioxide is gas. Second step, balance your chemical equation. So you check G is 1, G is 1. C is 1, C is 1. Oxygen are 3, 3. But here hydrogen is 1 and hydrogen are 2. Same thing with chlorine 1, here chlorine 2. So put a 2 here. So the ratio is 1 is to 2 is to 1 is to 1 is to 1. And mainly, mostly questions which are tested on moles, the equations are very easy to balance. You will be able to notice that they're not hard to balance. So after you have the ratio, now you check among the compounds which have been given, which one can I calculate its mass? I don't have, which one can I calculate its moles? I don't have the mass of G carbonate, so I cannot calculate the number of moles. But for HCl, I have volume and molarity. Remember I said 1m stands for molarity, so it means the molarity is 1. It has 1 mole in 1 liter. And also we'll calculate the moles of HCl. Then it will help us to get the moles of G carbonate. So moles of HCl, go back to your triangles. When you have volume and molarity, which triangle do you use? Use this triangle. Moles is molarity times volume in liters. And you remember your volume has been given in centimeter cubed. So use this formula to change back your centimeter cubed back to liters. So moles will be 1 times 20 over 1,000. Why 20 over 1,000? To change 20 centimeter cubed to liters, you divide by 1,000. So you divide here 0, 0. That gives you 0.02 moles. 0.02 moles. So ratio 0.0, those are moles for HCl, 0.02 moles. So if HCl has 0.02 moles, and here ratio is 1:1, it means automatically here is 0.01. The ratio is 1:2. So this is half of this. So you divide by 2. Also these are half of it, so 0.01, 0.01, 0.01. So which moles are you interested with? Calculate the RAM of G. G is an element in G carbonate. So RAM, what is RAM? RAM is molar mass. Molar mass is mass of a number of moles. Molar mass is, RAM is the same as molar mass. So molar mass molar mass equals to mass over number of moles. Were you given the mass of G carbonate? Yes, you had been given 1 gram of a certain carbonate. So its mass is 1 gram. 1 over, how many moles have we got that G carbonate has? 0.01. So you divide, you get 100. 1 divided by 0.01, you get 100. So the molar mass of G carbonate is 100. You have been given this, C equals to 12, O equals to 16. 100 is molar mass of G carbonate, the whole of it. But you want the only of G. So for G carbonate, it means 100 is molar mass of G plus molar mass of carbon plus molar mass of 3 oxygen. So I'll say X, because I don't know the molar mass of G, plus C, which is 12 molar mass of carbon, because it's only 1, plus 3 oxygen, that's 16 times 3 plus 48, should be equal to 100. Because the whole mass of G carbonate is 100. Then this is an equation, so it becomes X plus 60 to be 100. So automatically X is 40. X is 40. So it means the RAM of G is 40. So you have seen very clearly we are just applying the 3 triangles, and sometimes you apply. In this kind of question, you can also be asked, what volume of CO2 was produced at RTP? What volume of CO2? So volume, you say, if it's at RTP, 1 mole has a volume of 24. What about the moles which I have for CO2? 0.01. So I hope that is clear. I'll give you 2 questions to tackle. Then you can send your answers through our KUTV Elimu students WhatsApp group. You can also use the numbers below your screen to send your answers. Ask any questions regarding titration, because titration, I'd say that we can't handle it. It's a practical question, so you also have to do the actual titration. So keep your pens ready so that I can dictate the first question. When lead 2 nitrate is heated, one of the product is a brown gas. When lead 2 nitrate is heated, one of the product is a brown gas. Question A, write the equation for the reaction. Write the equation for the reaction. Question B, if 0.29 dm cubed, if 0.29 dm cubed of the brown gas was produced, if 0.29 dm cubed of the brown gas was produced, calculate the mass of lead nitrate that was heated. If 0.29 dm cubed of the brown gas was produced, calculate the mass of lead 2 nitrate that was heated. Question 2, phosphoric acid is manufactured from calcium phosphate according to the following equation. Phosphoric acid is manufactured from calcium phosphate according to the following equation. So in this question, you are lucky, at least you have been given the chemical equation, which will help you to get the ratio. So you take calcium phosphate plus sulfuric acid, you get your phosphoric acid, H3PO4, plus calcium sulfate. So the equation is balanced, so it helps you to know the mole ratio. So phosphoric acid is manufactured from calcium phosphate according to the following reaction. The question is, calculate the mass in kg, calculate the mass in kg that will be obtained if, calculate the mass in kg that will be obtained if 55 grams, if 55 grams of calcium phosphate reacts, if 55 grams of calcium phosphate reacts with the acid, if the acid is sulfuric acid. So if I have 55 grams of calcium phosphate, I react it with sulfuric acid. What mass of phosphoric acid will I get? Ratio is very key, so use the ratio. And here I'll give you the RAM. The RAM for phosphate, for phosphorus is 31. RAM of calcium is 40. The RAM of hydrogen is 1. And the RAM of oxygen is 16. Those relative atomic mass will help you to calculate the answer. So I hope the lesson today has helped you at least to understand something on moles, and that content will help you to even handle questions regarding titration. So let's meet during another lesson. Thank you.